All right, now we're going.
Hi besties, how are you doing today?
All right.
Okay, I said.
Sweet. All right, cool. All right, we're gonna start on. Yeah, we're gonna start on 39. Okay. This is tangent to theta, I'm gonna do parentheses, plus tangent 6 theta over 1 minus tangent to theta and tangent 6 theta. All right, cool. So once again, name of the game is like, do you see the pattern and can you associate it with an identity that you know? This whole section is all memory work, really. Until we get to it's all memory work. Everything up to that section of 65, when you finally hit number 77 and you're doing product of sum, those are still identities. Actually, yeah, they're all identities. The only real calculation stuff is going to be the rotation stuff from 89 on. Everything else is literally, do you know the identity? So what do y'all see here? What is the do you know what to look for? Okay. I'm glad we started here. All right. So you're basically just looking for the pattern. We're gonna just choose the first angle as alpha, okay? And we're gonna see the second angle, and we're gonna go, okay, well that's a beta angle. Well, these angles are the same, so I know that's an alpha angle, and that's a beta angle. So this is literally just asking you, do you know what the tangent sum of difference is? Well, and this happens to be in that exact form. So what tangent is, and I'll write it in its form here, if you have the tangent of alpha plus beta, the sum identity, that is actually going to equal tangent of your first identity plus the tangent of this, I said identity, angle, that's what I mean to say, plus, okay, so notice the angle or the sum here is here. So it's like sine in the way that it's the same, and then below the quotient line is going to be the opposite of that. And so that's how, and then this is multiplied. So this you need to know. This needs to be a flashcard, you know this kind of thing right here. And I'm gonna do it like this. So for the sake of the formula, because I think I made sure y'all knew what that means, right? So if they're the same, it means if it's plus there. If it's minus, it's minus. This one is it looks opposite. So if it's plus here, it's minus there. If it's minus here, it's plus there. So that is how the formula should look, okay? So it's straight up this. So if you're in that form, then you just condense it over here to this right-hand side. So all this ends up becoming is it just reduces down into your first angle, and since it's plus the second angle. Okay, and then what do you do? Yeah, you just simplify. So 6, 7, 8. Tangent of 8 theta.
So it's gonna give us that expanded version, and we have to go back to the simplified version.
Yes.
But will he make us do it?
Well, if you know it, then is it really going to throw you off? I mean, that's the thing is like the memory work is an equation. So if you know the right, you got to know the left, right? You can't, you know. So yeah, I mean, he could throw one or the other. You've got to see it. Mm-hmm. So that's just that you have to. Okay. All right, sweet. Okay. All right. Cool. Ready to move on? Okay. So we're gonna and so 41, if y'all look at, if 41, it's just using like, instead of a theta angle, it's using an actual angle, like a degree. Do you want to do that, or do you want to move to the next conceptual thing, like number, let's, time-wise, I think y'all, okay, well, how about this? Well, I'll just make I'm gonna erase this, and then we're gonna look at 41. And basically, I'm just going to be like, hey, does this kind of look like what we just did? Tangent of 300, this guy, minus tangent of 34 degrees, quotient 1 plus tangent . Right? It's kind of look like same song, different beat, or I don't know if that even makes sense. Right, like, so what do you do right off the bat? You just kind of like identify the angles, right? Like, first angle, second angle is, yeah, that is the first angle. Second angle looks like it's pretty much in the standard form. What if these were switched? Is that going to change anything? If 34 was right here, 334 was right there? It doesn't, because multiplication it doesn't matter. 3 times 7 is the same as 7 times 3. So if anyone ever wrote it different, it doesn't matter. That's what matters, that part. If that's, because 334 of that tangent minus 34 is different than 34 minus, right? Because order matters with addition and subtraction. Okay, so if it's in this order, y'all can crush the answer right now. What do we do?
It's 10, 300, right? We just combine.
Yeah, exactly. Yeah, because we took 334 and we used this one. This guy just flips. This is just as far as the formula. So 334 minus 34 gives you tan of 300. Is that a special angle?
Yeah.
It is a special angle. Where's it at? What quadrant? 4. Is tangent positive or negative in 4? Negative. All students take calculus C's in the 4, so yeah, tan's negative. What is the reference angle? 60. Tan of 60 is, we know it's going to be negative. What is tan of 60? There?
I didn't remember.
Yeah. Okay. It's the square root of 3. Okay.
Okay.
Just real quick on the quadrant 1, I'm just going to draw the first quadrant. This guy is pi over 2, and this guy is 0, right? Or, yeah, no, because we're in just quadrant 1. Okay, so when you hit that, we've got these 3 angles here. This is my 30-degree angle, this is my 45-degree angle, this is my 60-degree angle. These are all our references, so no matter where you're at, it's going to reference back to one of these angles. Like, we're talking about tangent. What is tangent of 30 degrees right now? This is just me practicing with you guys. I'm going to give you the first one. Okay? All right, tangent of 45. These are the easy ones. Real easy. The easiest one you had to memorize.
I didn't memorize.
You almost said it. I think you were mouthing it almost.
Is it
1.
Okay.
Yeah. Okay, 1. What are okay, and then 60 is square root of 3. We just did it. Okay. Just kind of like let that sink in for a second. Let it sink in for a second. That is have this kind of in your mind's eye. I don't know if this image looks good or whatever. It's tangent is only gonna be one of those 3 everywhere as far as it's a special angle, right? If it's a quadrantal though, a little bit different, right? Because like here at 0, what is tangent? Do you remember the formula you need whenever you're doing quadrantals? Do you remember those formulas? I'm just going to write it right here real quick. Tangent is equal to y over x, isn't it? Okay. So my y value.
Your what is your Your y is 0.
Y is 0 and my x is 1. Yeah, you're right. So it's 0 here. So tangent is, so this is my 0 radian, so don't get confused, but this is 0 for tangent. What about right here? What is my x and y right here values for?
Y1, x 0. So
Undefined. Undefined, yeah. So it's undefined right here. Okay, so now that's your full tangent in quadrant 1. Cool? Okay, that was just like you do need that, so I know that was a little bit off topic right there, but okay, awesome. We got that out of the way. Your answer is that. Nice. Okay. And then 45 is just like what we did last time where you make the sum and difference identity. You'll have like one angle and then you just do what it adds up to. Do y'all want to do one of those or do you want to like move past that? Basically, it's more of this. You're just working it from the other side. So now we're expanding it. So your answer earlier, are you going to see both? Absolutely. But when you see the other way, it's going to, and just real quick, we may not do the full one just to move along. But like, yeah, on 45, it says tangent of 105. And so, and this will be like, so on your test, if you see, let me try not to get too fast. 105, there we go. Okay, so is 105 a special angle?
No.
It's not a special angle. So that's your hint what you're going to do next. If it's not a special angle and I want the exact value, not a decimal, because you could just plug that into your calculator, right? It's going to give you a decimal number. But I want you to have an exact number. So if it's not a special angle, bell should be going off. What do? You remember?
Is it the...
Yeah, you split it up to make two special angles. You find two special angles that are going to give you an exact value. So what two numbers could you add or what two numbers could you subtract? And also, whenever you see a 5, what angle are you going to use? A 45. Yeah, so you're going to use some kind of 45 angle. So I just straight up go, okay, if I know that, I'm going to just straight up, I'm not going to make it complicated. I'm just going to subtract those two, 0, 60. Okay, great. I'm going to use a 60 and a 45. I'm going to add them. Done. And so, I say done. We'll done because we've already gone through the process. So then what do? We restate it and we say tangent and we say, hey, 45 degrees plus 60 degrees. And then this expands into what? It is probably, let's just fully do this because there is a few more steps here. So then what's my next step? What do I do? How do I write this?
Tangent of 45 plus tangent of 60 divided by 1 minus tangent of 45 minus tangent of 60.
Right, okay. And then, okay, now we just, in what I just wrote in red, now it's memory work. What is tangent of 45? 1. Boom, I'm going to cross that out. Okay, what's tangent of 60? Square root of 3, we just did it. Okay, that's out right here. Okay, what's the 1 of 1? It's just 1. What is 1? What is it? Okay, in math theory classes, you have to. They're called multiplicative identities and stuff. You have to prove like crazy stuff that we take for granted. You have to like prove it mathematically. And then again, we already said, so we know tangent is 1, and we know that this guy right here is the square root of 3. And now it's just algebra. So you come through and you say, actually, no, this is an important one to do because this is going to take something that you learned in the first section. So now we have that cleaned up to this, and then we have 1 minus 1 times anything is itself. Is that my answer? It's not my answer. Why is it not my answer? Or, well, it is the answer, but it doesn't look right. And then you were about to say, why is it?
You have to change it.
Yeah, we want to get rid of the radical. Not square, the inverse square. And you can say that. How do we get rid of it? Multiply by the conjugate. What is the conjugate? 1. Why is it 1 plus and not 1 minus?
Because the teacher told me to.
Yeah, because your teacher. Well, it's because of the FOIL process. When you FOIL, 1 times 1 is 1, and then you get a positive 3, and then you get the negative square root of 3. It's this changing of the sign is what eliminates the radical. That's the whole point. And then I put a 1 plus the square root of 3 up on top. Why? Why do I write it like this?
Because that's equal to 1.
It's equal to 1. You're not changing the equation. It's equal to 1. It's just a transformative process. That's all that's happening there. Okay? So now we do the math to go through here. So now we get 1 on top. We get 1 and 1 is 1 because we're foiling, right? Then we get 1 and that guy. And then we get another one of those. Since we get another one of them, I'm just going to go ahead and add it, right? Because we get 2 of those on top. And then the last one, square root of 3 times the square root of 3 is 3. And then on the bottom, what happens? We get 1 and 1 is 1, right? Then we do the outside, and then the inside cancels. That's what just happened. So we cancel that middle one, and then we just multiply the last 2. So what do we get? Minus 3. Okay, and then this equals 3 plus 1, 4, and then we have this. Because remember, this radical is a category of number that you can't mix with a whole number, right? Because this is, think of them as categories. Whole number, irrational number. You can't add those together. Not for exact purposes, you can't. And then right here we get -2. Are we done though? No, you gotta simplify. Okay, more simplified, okay? See, math is simple. We simplify all the time, right? So now what does that simplify to?
Simplifies to -2 plus -2 minus square root.
Yeah, right. Yeah, did you catch that? Because that negative, right? Because real quick, I'm babbling, but like I'm gonna separate the common or the denominator there, because the common denominator is in -2. So that's really what you're looking at, and when you simplify that, -2 minus the square root of 3, and there we have it. We're on, yeah. This is 45, right? Yeah. So there we go. Yeah. All right. So I think we are done with that section, because those 3 examples is there. And this process was the same process from question 1 essentially up till 53 on the homework. So like that, you're gonna do some kind of identity. Then you're going to do some kind of identity with with special angles that'll give you something, and then you're going to get something that's not special, and you got to break it up, and you're going to. So that is like the first half of the homework sheet. Okay, sweet, we're done here. Cool. Are we good to move on? Nice. Cool. So now let's hit the next concepts. So that's tangent with your sum and difference identities. All right. So next one, we're going to go up to 53 to the double angle identities. Okay. Sweet. So this will be 53. And we have, this is sine theta is equal to 4/5. And then it has a little statement over here, I'll do it over, where it says, where the angle is in between, it's going to be less than 90, but it could be equal to 0. It's going to be in between those, right? So in your mind's eye, you should already be thinking this kind of thing. What quadrant is that? 1, yeah. So you're thinking, they're not on there, but it should have little degree symbols. So we're in between this guy here. We're somewhere here in quadrant 1. Okay. All right, and then it's saying, and the question is find sine. Actually, we're going to say find sine double that angle is what we're looking for. Okay, so how do we break this information down? What do we do? That's a good question, right? Yeah, because it's sort of like doubling. Like, oh man, what's going on right there? What you do is you take what's given to you. Okay, so it's saying that we know this. We know sine equals 4 over 5. They're telling us, hey, it's going to be located here. What is? Well, you're kind of thinking in this XY coordinate system, and you're thinking about a triangle, and you're saying, okay, well, I know we're in this first quadrant, and we know that sine is, as far as SOHCAHTOA goes, what is sine? Opposite. So this ratio they gave you is telling you the sides of this triangle. Or that's what's happening. So we know because we know we're in the first quadrant, we know that our reference angle must be right here. It's got to be. Right? Because it's always to the ground. We measure from the ground kind of thing. So now with this ratio, where do I put those numbers? The opposite, 4. The hypotenuse is 5. Okay, nice. All right, and so what do we know about sine doubling? Okay, well, this is actually something, notice tools are very large for this section. Okay, tools, sine, I don't know if y'all remember, but sine double angle equals what? This is something you gotta know. Yeah, do y'all remember this one? This one is 2, actually, I'm gonna have to scoot it over a little, sine thing. Okay, so we have sine double angle is equal to 2 sine angle cosine angle. That. So this is a flashcard thing. Okay? And then you'll understand why the heck did we draw this triangle for, okay? And you'll see why. Like, so if we know that this is true, this sine, then we're sitting here and we go, okay, well, we can figure this out because we know that sine double angle equals this and this, okay? Do we know this one? It gave it to you. 4 over 5. That's what this is. So this guy right here is actually 4 over 5. That's what sine is. What's cosine? Do we know it? Right, because of because you either know your Pythagorean triples for this one anyway, or you figure it out with a squared plus b squared equals c squared. But yeah, you're right. You get 3 right there. So cosine is adjacent over hypotenuse. So we get adjacent over hypotenuse. So this is what we have in the 2. So we basically have 2 multiplied by all that stuff, and then we just finish it off. So what is this? So we have 5 times 5.
24 15, is that right?
So we have that, and then 4 times 3 is 12. 12 times 2, 24, and we are there. But what if I was to ask you, what quadrant is that in?
2.
How'd you figure that out?
Well,
This is a little extra, and I'll try not to do this all the time, but it's overlapping layers increase clarity.
I
Okay.
was thinking that's close to 1, and I guess 1 pi is 180 degrees. That's what I was thinking. But maybe
That's a good thought process. I don't, but this is what's interesting is this is just a number, but to make it equal to find out but in here I'll just get to that thought process is a good way to think. But what you would do is you would go like this. You would take this statement and you would say, well, we know that the regular angle is in between here. We know that? Well, all you would do is you would say, if there's a 2 there, to keep everything even, you have to divide everything by 2. You see what I mean? And that tells you where it's at. So then anything divided by that. Well, and also too, you can't just, or well, you can't divide that. So you'd have that, you'd get your angle, and then this guy here, 90 divided by. So it's actually even less than here. So it's not in quadrant 2, it's in quadrant 1. Say it's deceiving, right? Yeah. Isn't that wild? Yeah, so it's actually, you're not even in the whole quadrant. You're just in the first, you're halving it, and you have something even smaller. Isn't that wild? Yeah. Okay. Cool. All right. So that's 53. We didn't have to do this, but if I was to ask you where's that at? Because it is actually, that's always an intrigue. That's a great follow-up question. What did I just find, and where is it? And then you start building intuition with the unit circle. You start saying like, and you also start building intuition with angles. Like you'll see something like that. But riddle me this, that is close to 1, isn't it? Isn't 45, tangent of 45, 1? It's kind of like a weird, so it's almost 1. That's kind of weird. Like, I don't know if that might not be correct thinking, but you know what I'm saying? You're thinking of the 1. Anyway, so let's move on. So that is 53. Let's. Do y'all want to do one more double angle, or actually no? Let's move on because that was. Let's go to 57. I just want to hit the first ones of each section. I think that's the most helpful. And then, because there's little tricks that are going to be in the other ones, but the only trick is just kind of like just how solid do you know your stuff, I guess. You know, your identities, and then there's just like probably little like arithmetic things or whatever, you know. So 57. We have sine is equal to 12 over 13, and then it's stating where the angle is going to be in between. Oops, I think they had. Yeah, in between there. And then they're asking you find cosine. That's weird. They gave us sine. They didn't give us cosine. Double angle, right? That's what you might be thinking. And so, what do we do here? How do we solve this one? And I'm just going to say, hey, rely on what we just did. Just because these change doesn't always mean the method changes, right? You know what I mean? So,
I guess we'll start with finding which quadrant we're in.
Yeah, I would kind of think like that. So I would just kind of draw like this XY coordinate system, and I would say this instruction right here, it's telling you the angle is between where?
Pi over 2.
Pi over 2 and pi, which is what quadrant? 2, yeah. 2. Yeah, so we have pi over 2 and pi. We are here, okay? What other information, okay, so, and this may not be a bad process, so you're not like overlooking stuff. When you use something in math, sometimes it's like, okay, I don't need to look at that anymore. I'm done. So what's the only other piece of information we have left? That's not the question.
Well, I guess we know what this line is.
Yeah, so what do?
We can draw the triangle.
Draw the triangle in the second quadrant, and then like it gives you your information you need. We're always dealing with these right triangles in here. So and we know that the reference angle must be right here. We're not looking up here because we're always, reference is always to the horizontal, the ground level. So then, because of sine, what do we know about sine?
We know that the opposite side is 12, and my hypotenuse is 13.
That's absolutely right. So so then we come down here and we know from our reference angle, this guy's got to be 12, this guy's got to be 13. We're looking for cosine. What do we know about cosine double angle?
It's another flashcard.
It's another flashcard. Let's add some to our giant toolbox over here. This is a big, heavy toolbox that you don't want to carry up 7 flights of stairs. But sometimes you have to. So cosine double angle, this one's going to be a little bit hairy. Does anybody know the first one? And when I say first, do you know that alludes to there's 3 of them? There's 3 that are equal to this one.
It's that one.
Yeah, do you remember what it looks like? Okay, it is cosine squared theta minus sine squared theta. It looks very similar to the Pythagorean identity. And this is one thing I always like, this is how I always remember these. Cosine, the identity, always has the trig of the identity or the relative one first, right after the equal sign. So that'll help you, so you don't mix up and say sine squared minus cosine squared, because that's different. That's a different identity. And so now that's only one of them. Then we have, and I'll just give these to you. You have 1 minus 2 sine squared theta. And then you have 2 cosine squared theta minus 1. Okay. And notice cosine is still squeezed up over here next to that one. Sine is still over there. It's just kind of like a little flip up. So that's these guys right here. Okay? They're good to know because sometimes when you know these, they can actually give you less work to do. This is one of those things where cutting corners doesn't help you. The more you know, the more work you do early can actually save time because, like, you don't actually need to solve this triangle if you know more about that. Why? The second one is a sine. We know what sine is. Let's use that one. Let's just kind of, this is an example of not cutting corners is going to like give you, we know that cosine double angle is equal to 1 onto 2 sine squared of that, right? So then, do we know sine? Yeah, it's, yeah, because imagine this wasn't an easy triangle, an easy triangle. So if we'd say 2, and then be careful how you write this because this sine squared function, if you rewrite it, you can also rewrite it like this. That little 2 is really there. It's just in math notation they just put it in between here because they're letting you know that the function is squared, not the angle. So when I do this, I'm saying that whole function is being squared. These two are the same thing. Okay? So whenever you write, and the reason why is when you write that, you're actually saying, 12 over 13 squared is how you fill that in. Okay, so then we solve this guy. We know that this is going to be a 2. We know that 12 squared is 144, and we know that 13 squared is 169. I think, right? Check me on that.
Yes.
Okay. Okay. So then so for what, before I write, and then that one's right there. And so then we just simplify this up. So what I would personally do is I would rewrite 1 as 169 over 169, right? Because anything over itself is 1. Then I would multiply that by 2, so you get 2, 2, and 8 over 169, right?
It's actually...
Did I mess up?
It's not 114, it's actually...
Oh, sorry,
144.
sorry. 144, thank you. I did the 13, and I couldn't get the 12. The 12 is the one you know. Okay, so let me redo this. So then we get 188, thank you for that. This is why I always use my calculator. I try to look cool and not use it, but I can remember formulas, but multiplying all this up. All right. And 2, that should be 2. See, look, I'm not even 2. 8, 8, 2. There we go. Okay, awesome. And then you just solve that out. So I would do 169 minus 288, and then you'd have 9 over that 169. It doesn't, and I don't think it doesn't reduce down, so we're good. So you should get a negative. This becomes negative 119 over 169. Right on. Answer. Right on. Okay, so this is knowing where you're at is really important, right? Knowing SOHCAHTOA is really important. Then, so you got to kind of know 3 things. Then you got to know and you could have used this one, but if you use that one, you'd solve the rest of the triangle because you would have to have that cosine identity. But because we knew more than less, we just chose one where we already have the information. And so that's kind of like an example where you can, so awesome. Okay. Let's I think y'all will be fine because you can figure out the rest of that section with that, right? Okay, so let's go into double angles. Okay. Or well, we are in double angles still, but we're gonna do tangent double angle. Okay.
What about on like the complicated drawing thing?
What you said? What now?
Isn't tangent like always complicated thing?
It's got a complicated look. Wait, double. No. The half angle one is the one that's complicated. The double angle one's not. The double angle one is easy. What is actually we need to know? We got to add to our tool list and do.
I feel like I'm in an episode of Mickey Mouse.
And then let's see. We're getting close to 15 minutes, and we still haven't done half. Oh, I've been talking too much. Why don't we? Wait, is this Wednesday? Oh, we have another day. Okay, let's keep moving forward. I thought it was Thursday already. Okay, so
It feels like this.
it does. Yeah, it
You
does.
said it was Thursday. You said you thought it was Thursday. Maybe you think it's not.
Okay, so we have, this is 61, we have cosine theta is equal to a over 7. Anytime you see cosine, a trig function equals some ratio, you should be thinking triangle, like, or well, I guess maybe not always, but that's one, we're in this section, so you should always be thinking triangle. So 270 degrees. It doesn't have the degree symbol. That was just a thing because of the way the printer is 360. Because if it doesn't have the degree on it, it's talking about radians. Because you could have 270 radians, and that's different than 270 degrees. Those are different. Fine. What's that?
I was going to say, what is 270 radians?
Yeah, what is it? How much is a radian?
Oh, just kidding. I don't know.
A radian is about 57 degrees. So you'd have 57 degrees multiplied by, that. Or you would take, like 270 radians. All you would do is you would multiply and you want to know what your radians are, or degrees. So in your degrees, you would have 180 degrees over pi. And then you would multiply that out and that would tell you more exact. But if you also know that a radian is about 57 degrees, then you could just say 57 degrees and all that. Okay, there's that little short thing. Okay, and then we're saying find tangent double angle right there. Okay, we start off. What do we know, or what's our first step? Yeah, let's go ahead and get this guy kind of figured out. And where are we? What are we in between? Or what quadrant are we in?
3/4. Wait. Yeah, 3/4 pi. 3 pi over 4 and 2 pi, right? No.
Wait, no. Where are we just at? What quadrant are we? We're in the fourth quadrant because our angle's in between 270 and 360. So we're here, and then I'll try to. I think you may be ahead of me. So we're okay. So now what do we do? Draw the triangle. Okay, and where does we always draw the triangle to the floor. So and this gets really important, and we are going to find. Actually, no. This is great. This is actually great So our reference angle has to be right here. It's always next to the horizontal and then the hypotenuse coming out of it. Okay, so with this reference right here, what is cosine? What cosine's telling us where to put our numbers, which is what?
Adjacent then.
So adjacent this guy, right? And then our hypotenuse is. Okay, now I do want us to find this side. And I want y'all to find this side real quick. I want y'all to, and what you use what to solve? Yeah. There we go.
15.
Yes.
Did y'all get 15? Okay. Is it 15?
Yes.
15? Are you positive? Is that your final answer?
I am absolutely sure.
What if I told you you were wrong?
Is it negative?
It's negative 15.
Oh.
This is why you draw the triangle. You have to know why, because when you start doing your SOHCAHTOA stuff, those signs matter, right? So if this isn't negative and I want you a sine angle in here, it's not going to be negative. Is sine negative in fourth quadrant? You better believe it is. So this is why you draw that, okay? So you get the number, but the location matters, okay? Awesome. Learning moment.
Okay.
Teaching moment. Right? Okay, so what do we know about tangent double angle? This will be adding to our tool list. Do y'all know it?
Look
Well,
at my notes.
Okay, we'll check this out. You actually do know this one. Okay.
Oh wait, it's
Because-
just sine or cosine, right? No.
Well, you can use that, but then you'd have to do sine double angle over, and then that would be even more work. Okay, but okay, check this out. You know, and riddle me this, tangent sum identity, don't you? You know that it's angle plus some angle is going to be some tangent angle plus some tangent blah blah blah. That's a minus. We have a tangent. Sorry if I'm not writing super clear here. I'm gonna make a point. You know this, right?
Yeah.
Well, riddle me this. What if I came in here and I said, actually let's do it. What if I said, hey, what if those are the same angle? What if I cleaned that up? This plus that gives you how many? 2. Gives me 2. Okay, well, if those are the same, can I clean that up?
Yeah.
What does it clean up to?
So we change it there.
Over 1 minus 2 tangent.
Not is over 1 minus
Oh, tangent theta squared.
tangent squared theta. You do know it.
That's complicated.
That's there you go. You do know it. So that's what we're going to use.
Sick.
Yeah. So now what is our tangent? What is our tangent ratio?
15 over 8.
Because it's
Or negative 15 over 8.
yeah, yes, yeah. Opposite over adjacent, right? Opposite over adjacent. So we're gonna rewrite this, and we have 2. Actually, let me go to because that was to make a point. And we have 2, and we have tangent. Oh, sorry. Tangent is going to be our opposite over our adjacent. So it's negative 15. This is where that will royally mess you up right there. Okay? And then we have 1 minus, and then we know that that's going to be a negative 15 over 8 squared. I should make those look more like 5. So S is 5, 15. Okay? We get that guy. Okay? And now we're just kind of doing some algebra. So you can reduce the 2 and the 8, and that'll give you just a 1 and a 4, right? So then on the top we end up having this negative 15 over 4, right, on top. I'm going to cross all this out, and it goes to that guy. Okay, and then on the bottom, if we, I don't even know what 15 squared is. 225, you're right, it is. Isn't that right? You did that right? Perfect, beautiful. I'd like to have those memorized better at some point. That'd be awesome. Okay, and since we're squaring that negative number, it's a positive, right? So I have 225 over 64, right? 8 times 8 is 64. Okay, and we still have our 1. This is positive. So then we still have our 1. So let me clean this up down here. So I'm actually, yeah, let's just restate it. So we have a negative 15 over 4 over, and that 1, I'm just going to go ahead and change it to 64 over 64. That's just that easy fix, because anything over itself is 1, and we know that we have this 225 over 64, right? Okay, so now we're going to clean that up. So what is, where's my calculator? What is 64 minus 225? Yes, correct. 1. So we get this, negative 161 over 64. Okay? Then what do we do? I want to make sure is that even in there?
You have to change the
Okay.
15 over 4 to match the 64 and then.
Well, before I would even, well, yeah, like whatever process you want to go, this is what I'm going to do. I'm just going to do the whole like, kick flip and, kind of thing like that. So, we would take this expression and we would multiply it, because this will eliminate the bottom, won't it? You know what I mean?
Oh, yeah.
Those cancel, and now we're left with this. And so the 4 and the 64, I believe, can cancel, right? Because like you can put 1 in there, I think it's 2, 24, that's 16? Is that right? Did I do that?
Yeah.
Okay, so, and anyway, and so this is just however you want to do this, right? So, and then the 4, if we're going to cancel that, that would be the 1. So you would basically get, and you could have just done, in your calculator, you could have just done negative 15 over your 4 and multiplied it by 64 over your negative 161, and you would have gotten let's double check our answer. Cool. Feeling good? Bam. Okay, so isn't that cool? You did know double angle. You didn't have to like. It's funny because that's actually where these kind of come from, right? Like y'all are seeing how interconnected everything is. It's so interconnected. So in our toolbox over here, we'll have our tangent double angle is equal to 2 tangent theta over 1. What's nice is it's always minus there because you had to add those from the sum identity to get it. Isn't that cool? And so that's another tool in the box. Okay, nice. Okay. I'm erasing this.
It's so clear that is a thing that is happening.
That is what is going on. Yeah. Okay. Let me see. We're close to 7. We can stop there. We can hit. Where did we stop? What is that? 61.
Oh, 61, yeah.
That's what we stopped. Yeah. Awesome. So we could pick up. We could go from 65 because so basically half angles is where we would start, and that's kind of nice because then tomorrow we'll get through those topics. If you want, y'all can sit on that rotational stuff for a second, and then we'll go through it. Even if we don't get to it, or we may even start with that just to make sure we get, because that's the rest of them are just, do you know your identities? And then the rest of it, actually while I'm talking, I'm gonna make sure they can see the rest of the toolboxes. These are all the tools that you need, guys, right here so far, up to problem 61. And bye-bye.